we're still on that right triangle thing. In fact, this whole chapter is about right triangles. Even though towards the end of this chapter it may not look like it's about right triangles, but it all is. So one of the most popular, I guess, things about right triangles is using the Pythagorean theorem. And you guys probably already familiar. Did we do any? I don't know if we did. We didn't do that at all, did we? In the when the seniors were all here. Yeah. So this will be the first time. Good. That's why we're doing this section, or this chapter out of this book, because I want to hit some stuff that other book really didn't cover. All right. So now Pythagorean theorem only works with right triangles. Right? You can only use Pythagorean theorem with right triangles. Make sure you remember that. Alright, so let's grab a right triangle and put it right here. Alright, and you've seen this before. You did this in Algebra 1 probably, you did it in Algebra, or in Geometry, you did it in Algebra 2, right? So you've seen this a lot. Here's a right triangle, and we'll call this is the leg of the right triangle, we'll call that A, we'll call the other leg B, and we'll call the hypotenuse C. Alright, so we always call the hypotenuse C. Now it doesn't matter if I called this A or B. I could have called this one B or this one A. As far as the legs are concerned, it really doesn't matter. Just call one A and one B. And what does our Pythagorean theorem say? It says that A squared plus B squared equals C squared. Alright, it's as easy as what? A, B, C, isn't it? Alright, so A squared plus B squared equals C squared. That means I take this leg and I square it, I take the other leg, I square it, I take the sum of those, or I add them up, and that should equal the square of the third side. Alright? So let's stick some numbers in. Let's just use this triangle, so I'm going to draw another one. Again, you've seen this before, so I'm not going to go through a lot of the details of it. I'll make this really easy. This is 3 and this is 4. We got to find this. I'll just call it X because they don't always call it C. And you already know what it is, don't you? All right. But let's do it by Pythagorean theorem and let's see something. All right. So what are we going to do? A squared plus B squared. We take the two legs and we square them and add them up. So I'll take the 3 and I'll square it. Take the 4 and I'll square it and I'll add them up. And that should equal the hypotenuse squared. Here's the hypotenuse. The hypotenuse, remember, is always opposite the right angle. Do you remember that from geometry? Okay, so that's equal to x squared. And now we just work this thing out and solve for x. 3 squared is 9, 4 squared is 16, and that's equal to x squared. You add them up, that's 25, which is equal to x squared. You get x by itself, which we did the whole other lesson, right? Took the square root, so x is what? 5. Yep. So x is equal to 5. Look at that. That's kind of cool because look, it goes in order, right? 3, 4, 5. Does it always look like that? Does it always look that pretty? No. Okay, that's a special triangle, okay? And we actually call it a Pythagorean triple. Pythagorean triple. I don't know if they talk about that on this lesson or the next one. Let me see. Oh, it's on this one. If you look, no, you don't have a book. There's a bunch of different Pythagorean triples, which means all three sides are nice whole numbers. Okay, that's not always going to be the case. A lot of times you're going to have square roots for some of the sides and stuff like that. Okay, but when you get a right triangle with all three sides coming out to be nice whole numbers like this, we call it a Pythagorean triple. This is one of our most popular ones, and that's a 3, 4, 5 triangle. What if I did this? What if I said this was 6 and this was 8? What do you think, without doing any real hard math, without doing even the Pythagorean theorem, what do you think this would be right here? It's 10, because what did we do to that 3? We doubled it. What did we do to the 4? We doubled it. So what are we going to do with that 5? We're going to double it, and that's going to be 10. So you have a whole bunch of combinations of 3, 4, 5, don't you? You have 6, 8, 10, right? You could triple it, you could times it by 4, times by 5, and you could have a whole bunch. But your main one is 3, 4, 5. Okay? That's very helpful. If you take the SATs, which you'll be, have you taken the SAT yet? Probably be taking it this year. You're taking the ACT? Yeah, probably even on the ACT. There'll probably be situations where you don't want to waste your time because it's a time test, right? You don't want to waste your time. You should just be able to look at it. And if they didn't tell you this right here, you don't have to go through the whole Pythagorean theorem. All right? You can look at it, 6, 8, oh yeah, that's 3, 4, 5. 6, 8, 10, right? That's the purpose of learning Pythagorean triples. You could always do Pythagorean theorem, you could always put it into a calculator, but this just kind of speeds things up a little bit so you don't have to sit there and do a whole lot of work. Make sense? Now there are some other Pythagorean triples. Let me just list them. I'll list them. This is 3, 4, 5. And there's some other ones that come out, right triangles that all the sides come out nice and whole. 5, 12, 13 is one. 8, 15, 17 is another. And then there's another one, 7, 24, 25. Now there are more, but the others are probably a lot more rare than these. All right, so those are your Pythagorean triples, and that's very helpful. Do you have to know them? No, you don't have to know them, but it definitely is, it's helpful from time to time to know those. All right, and again, so for instance, if I said, let's get rid of this and this. What if I said this was 8 and this was 17 and I had to solve for this? Now you could do Pythagorean theorem, couldn't you? You could go x squared plus 8 squared equals 17 squared. Then you do all the work, all right, and then you see what you come up with. In fact, let's do that just to show you. All right, so let's go x squared plus 8 squared, and that should equal 17 squared. All right, so this is x squared plus what? 64. So I don't even know what 17 squared is. Anybody got a calculator? I should know. It's 289, I think. I should know that. I think it's 289. Let's see if it is. 289, I believe it is. So now what do? We subtract 64 from both sides. Good. So x squared equals, what's this? 225, right? 225. Take the square root of 225, and guess what you get? You get 15. Now, I could have gone through all that work, but that took me like a minute. And you say, oh, big deal, it takes me a minute, or even 30 seconds. When you're doing a whole bunch of problems, and you know, the little 30-second things that you do when you're taking a time test really add up, don't they? And so you want to make sure you do things as efficiently, as quickly as possible. So then you can spend time on the ones that you really have to think about, you know, and you have to do a lot of work on. So I could have just, instead of doing all this, I could have remembered my Pythagorean triples, right, which said what? My two legs are 8 and 15, the hypotenuse is 17. And so, well, I got one leg is 8, and the hypotenuse is 17, so what does that mean about this other leg? This should be 15. So if you recognize 8, 15, 17, it saves you all that work right there. And we're all about saving work, right? All right. I'm the same way as you are. I want to do the least amount of work that I can to get the answer. And so if you recognize this, but it takes a little bit of effort, right? Memorizing them and learning them. But once you learn them, then things go a lot quicker. Make sense? And again, you could always say, what if that was 16 and what if that was 34? You look at it and say, oh, 2 goes into both of those, right? 2 goes into this 8 times, 2 goes into that 17 times. Oh, yeah, what do I got? I got 8, 17. That must be 8, 15. So what's this going to be? It's not going to be 15. What's it going to be? It's going to be 30. All right? Does that make sense? So that's quicker than doing this if you recognize, you know, the 8, 15, 17. All right? So that's Pythagorean triples. Let's see if there's anything else. Let's do one that does not come out nice and perfect. So let's do one like this. Again, you can only use Pythagorean theorem with right triangles, so don't try to use it with an obtuse or an acute triangle. This is 25. All right. Now here's a common mistake people make. You know what a lot of people do? They'll take the two sides that they give you. They'll say that's your A and your B. They'll go, you know, 22 squared plus 25 squared equals x squared. But it's not what we do, is it? What do? What's the A and the B? The A and the B are the two legs, aren't they? All right, and then the C is always the hypotenuse. So make sure you do that. Don't just take the two sides and square them and add them up and set them equal to the missing thing. I'm sorry, what'd you say? Oh, it connects both legs? Yep, that little box does connect both legs. Oh, I got some in my throat. Excuse me. All right, so let's do this. You can start off 22 squared plus x squared, but I don't know. I always like to put the variable first. So x squared plus 22 squared equals 25 squared. This is not one of my Pythagorean triples, though, is it? So I've got to put this in a calculator, and I should have my calculator. Give me a second here. And let's go to that, and let's go to that. There we go. All right. And there we go. So, oh, I should do some math first, right? I got to get x by itself. So what do I have to do? I have to subtract 22 squared. Watch, I'm not even going to do that in my calculator just yet. I'm going to do this. I'm going to say x squared equals what? 25 squared minus 22 squared. And then what do you do with that? Take the square root of it, right? You don't have to write the square root there, but I think it's a good idea to write like this. All right? And then so now we just stick it on our calculator. So it's 25 squared minus 22 squared. All right, and I'll put equals, so it's 141, and then you just take the square root. Oh, actually, I don't want to take the square root of that because it's going to come out to a decimal, and I want you to write it as a simplified answer. Okay, so let's write it like this. So x equals the square root of 141, right? Let's see if anything goes into this. Let's see if we can simplify this. 2 obviously doesn't, so 4 doesn't, right? Does 3 go into this? How can you tell if 3 goes into it? Well, you could always stick it in a calculator, right? But you could add up the digits, right? 1 and 1 is 2 and 4 is 6, so 3 does go into it. So there's a chance that 9 goes into it. Why did I pick 9? Why did I automatically go from 3 to 9? Because I could take the square root of 9, right? So let's just try that. Let's go 141 divided by 9. Let's see. No, it doesn't. Let's try something else. Or it might not even go. There might not be anything that goes into it. I don't think there is, because 5 definitely doesn't, so 25 doesn't, right? 16 doesn't go into it, right? I'm trying to think of all the things I can take the square root of. 49, does 49 go into it? Whoops, a little too much. 141 divided by 49. Nope, that doesn't go into it. So guess what? This is probably already simplified right there. Okay? And that's what I would do, okay? There may be other better ways to figure out if this simplifies, but I just try a bunch of numbers, Try 4, try 9, try 16, try 25, right? And you don't even have to try 36 because if 4 doesn't go into it, 36 doesn't go into it. You could try 49, right? See if that goes into it. And if you've tried all those, most likely probably nothing else goes into it. Are you good with that? Pretty easy, isn't it? All right, that's it. So I'll give you a worksheet on this. It'll say 8.2. That's it.